Okay, you have one warm-up for today, and I would like you to solve this absolute value equation. And remember, yesterday we talked about absolute value equations. You have to set them up as two separate problems. So the first thing I want you to do is isolate the absolute value sign, which means you need to get this by itself. So pause the video and go ahead and solve this absolute value equation. Okay, isolating the absolute value sign means that we need to first get rid of this minus 8. So we need to do the opposite operation to move it to the other side, which means we need to add 8 to both sides. So adding 8 to both sides, you're going to end up with 2 times the absolute value of x plus 4 equals 20. Okay, absolute value sign is still not by itself. Now this is multiplying by 2, so we need to do the inverse operation, which means we need to divide by 2. So dividing both sides by 2 will get the absolute value sign by itself. Once the absolute value sign is by itself, that's when you split it into two separate problems. Because remember, this value inside here could equal 10, and it would make that true, or this value inside here could equal negative 10. Absolute value of negative 10 is still 10. That's why we need to split that into two problems. So splitting it into two problems, we'll drop the absolute value sign. X plus 4 equals 10. X plus 4 equals negative 10. And then you just subtract 4 from both sides, and you'll end up with two values that could go inside the absolute value and make that a true statement. X equals 6 or x equals negative 14. Now if we go back up here and check it, if we make this 6, we have 6 plus 4, which is 10. 10 times 2 is 20, minus 8 is 12, so we know that 6 is correct. Our second answer was negative 14, so if we substitute negative 14 in here, negative 14 plus 4 will give you negative 10. Take the absolute value, it becomes positive 10. Multiply by 2, it becomes 20. Subtract 8, we get 12. Okay, now we're going to go, I'm going to have you go over your homework questions. So pause the video and go over those answers. The next thing I'm going to have you do is to take notes over section 2.8b, which is number 6 in your notes. Concept number 6. Now this is similar to what we did yesterday, except for being absolute value equations. Now we're dealing with absolute value inequalities. And again, remember inequalities, instead of an equal sign, we have one of these for inequalities. Okay, generally speaking, what I want you to think of, if you have a greater or greater than or equal sign, think of, spell the word, notice I spelled the word incorrectly here, great or. So great or generally means that you have a split graph. Now these circles could be open or closed depending on here. They would be open if it's a greater, they would be closed if it's a greater than or equal to. Less than, and again notice that I spelled this incorrectly, and means that you have an overlap in your graph. We talked about that yesterday. So there are exceptions to each one of these, and we'll talk about that more in a little bit. But in general, when you have a greater or greater than or equal to, your graph is going to be split because it's or, and if it's a less than, your graph is going to look like dumbbells. Okay, couple of things. Isolate, or some steps to solving the absolute value inequalities. Same thing as yesterday. You want to isolate the absolute value expression. Sometimes it's already by itself, so it may not be necessary. Second thing is you rewrite the absolute value expression as a compound inequality, so two different inequalities. Step number 3, when rewriting the second inequality, you must remember to flip and switch. So I'm going to underline this, flip and switch. And when I talk about that, what I mean is you're going to flip the inequality sign and you're going to switch the sign of the number. Okay, the third thing is you solve each part of the compound inequality for x, and then check your answers to see if they make sense. Okay, let's do an example. We want to solve and graph the absolute value inequality. Here's our inequality. Step number 1 says that we need to isolate the absolute value. Well, this is already by itself. So once it's by itself, we go to step number 2, which says rewrite the absolute value expression as a compound inequality. So we need 2 different inequalities. Now, yesterday when we rewrote it, it was just an equation. So what we did is we said 4x minus 8 equals 12 and 4x minus 8 equals negative 12. Today now we have inequality. So what we're going to do, whatever this inequality sign is, we're just going to rewrite it here. So we don't do any changing there. But when we go over to here, this was positive. This one has to be negative. Now think about what happens when you divide by a negative number. Think of dividing by 12 by a negative 1. It reverses this inequality sign. So instead of being greater than, this is going to be less than. So this is the flip, flipping the inequality. Oops, I don't need to make that equal there. This is the flip. You're flipping the sign and you're switching the sign of the number. And now you just go ahead and solve it like you've been doing. We'll just add 8 to both sides here, and we get 4x is greater than 20. Divide by 4, and I ran out of room here. I'll just write it right here. So we're dividing by 4, and we get x is greater than 5. Okay, so let's go to our number line here, and we'll go to 5. No underline here, so the circle is open. And arrow, it's greater, so it's pointing to the right. And now we will solve this inequality, adding 8 to both sides. Line that up a little bit better. And we have 4x is less than negative 4. Divide both sides by 4. And we have x is less than negative 1. So circle is open because there's no equal sign under there or part of an equal sign. We'll go to negative 1, open circle, and pointing to the left because it's less than. Remember, L-E-S-S, less than. Less than goes to the left when your variable is on the left. Okay, so that follows what we know, that OR is great OR, so OR is generally a split graph. All right, now we're going to move on to example 2, and this one we don't have our absolute value sign isolated. So the first thing that we need to do is we need to get this by itself. So to get that by itself, we have to, this is an adding 12, and I just drew right through that, so let me do this. And I did again. Want the absolute value sign by itself, so we need to subtract 36 from both sides. And when I subtract 36 from both sides, I'm left with absolute value of 3x is greater than negative 24. Now that my absolute value sign is by itself, I can split it up. And I think I just might have ran out of room, so I'm just going to come over here. So I have the absolute value of 3x is greater than negative 4. Again, once this is by itself, I can split it up. So I'll split it up into, the first time I'm going to write it without the absolute value sign, so 3x is greater than negative 24. The second time, this stays the same, so it's still going to be 3x, but now I need to flip the sign and flip the inequality and switch the sign of the number. So now I have 3x is less than, this was a negative 24, that becomes a positive 24. The sign gets flipped, inequality sign, and the sign of the number gets changed. And now just go ahead and solve it. So we can divide both sides by 3. And x is going to be greater than negative 8. Divide this side by 3 and this side by 3. And we have that x is less than 8. So again, there's no part of an equal sign under here, so it's going to be an open circle at negative 8. And this says greater. Open circle at 8. And this says less than. Now this is going to be one of our exception. We isolated the absolute value sign, and this says OR. Or means you should have a split graph. This is one of our exceptions, and you had one yesterday in your You Try It. So what happens, or one or the other has to be true. The number has to be greater. Oops, that's not negative 8. I guess I need to put my glasses on here. This is negative 8 here. So that's going to go this way. Okay, so or, one or the other has to be true. So what happens, all of the numbers greater than negative 8 will work, or all of the numbers less than 8 will work in this inequality. So since all of them will work this way, all of them will work that way, and because it's an or, one or the other can happen. So basically what's going to happen, it's going to be every single number on the number line, because all of these work, all of these work, so basically covers the whole number line. So when you have or and you have an overlap, so if it's great or greater than or equal to, and you have an overlap, it's all real numbers. Now if this had been less than, then we would just have this little overlap right here. So just be real careful if it's greater than or equal to, or less than and less than or equal to. Okay, you have some You Try It questions to work on and also a worksheet.